Welcome to the deep dive. Today we're talking about something that if you're building anything serious on Google Cloud, you just can't ignore it.
hmm
We're talking about something that touches multiple teams, different environments, and maybe most importantly, multiple invoices.
That's the one.
We are going right down to the absolute bedrock of Google Cloud architecture today. We're talking about the GCP project.
It sounds basic, but it's everything. Honestly, if you don't get this right from the start, you're setting yourself up for a world of pain later.
Absolutely. I mean, if you've ever felt like you're just wrestling with resource sprawl or you have that constant worry that your dev environment could, accidentally touch production data,
Yeah, that's a nightmare scenario.
it is. So this deep dive is really your lifeline. We've gone through a whole stack of architectural best practices, a lot of technical docs to give you a complete shortcut on how to define, secure, and organize everything you run, all using the power of the project container.
It's so true. The sheer speed of cloud deployment can lead to what we call organizational chaos. It happens so fast if your foundations aren't solid.
Organizational chaos. I like that.
Yeah, we always talk about infrastructure as code, but today we're really talking about organization as architecture. It's about partitioning things effectively. That's paramount for managing scale, for security, and like you said, for keeping costs under control.
And that organization, it really does start and end with the GCP project. So let's just unpack that definition for a second. At its most simple, what are we talking about?
It's the fundamental, inescapable container for every single thing you deploy.
I mean everything, like VMs, databases.
Literally everything. Your virtual machines, your Cloud SQL databases, your storage buckets, all your API configs. Everything lives inside a project.
And that's a key distinction, right? Because in some other clouds, it feels more like a label or a tag.
Exactly. In GCP, the project isn't just a suggestion. It's a mandatory hard boundary. It serves as this logical wrapper, a kind of dedicated sandbox for all the resources related to one specific thing.
And that one thing could be
What?
an application, a team.
It could be anything, really. A
So-
single application, an internal team's workspace, a specific environment like staging or production,
Yeah.
or even an entire business unit.
So, okay, the core takeaway for you listening in, whether you're an architect, an engineer, or a manager, is this. Every single item you deploy on GCP, without exception, must belong to a project.
It has to. It's the definition of context. Without a project, a resource simply cannot exist. It's the starting point that defines everything else. Who can access it, where it lives, and crucially, who pays for it.
Okay, so we know what it is. Now we need to dig into the architectural weight it carries, because it's so much more than just a folder. It's really an engine of governance.
It is.
Let's get into the 4 critical roles that projects play, the things that help you maintain a secure and manageable cloud environment. Starting with, I think, the most tangible one, resource isolation and security.
Resource isolation is, it's the project's immediate superpower. Right out of the box, by default, resources in one project are logically and for all intents and purposes physically isolated from resources in other projects.
So if I spin up a VM in Project Alpha,
It has no idea that Project Beta even exists. There is
Sure.
no inherent ability to see, let alone interact with, say, a cloud storage bucket in Project Beta.
and that default isolation is so important. It enforces that principle of least privilege right from the get-go, from the architectural drawing board. It stops those disastrous, unintended interactions.
That's right. Just think about how industries deploy things. You have large enterprises handling incredibly sensitive, high-value data.
Right.
So take a company with a CRM application, a customer relationship management system. It's full of customer PII, and that's running alongside their ERP system, their enterprise resource planning.
Which is mission critical. Inventory, financial.
The whole business runs on it. So you have
Yeah.
two distinct systems, two totally different criticality levels.
So this pattern is obvious.
The architectural pattern here is to place them in separate projects. The CRM system runs in, say, the cron prod project, and the ERP system is in the prod project.
And the benefit there is containment.
A huge benefit. If an engineer deploys a bad config or a really severe bug pops up in the CRM app, let's say it starts making wild API calls, that fault is contained. It's stuck entirely within the cron prod boundary.
So it physically cannot mess with the ERP system.
It cannot inadvertently affect the resources, the database, or the networking of that mission-critical ERP system. That boundary is your default line of defense.
It's like a firewall against human error and bugs. And you see this mirrored not just between departments, but across the different lifecycle stages of a single app, which is, that's essential for CI/CD.
That's environmental isolation in practice. A great example is if you're developing a new high-scale mobile game backend. You do not want your experimental, often unstable development work crashing the live service.
Of course not.
So you set up a three-tiered structure: GameX development, GameX staging, and GameX production. Your devs can iterate, experiment, break things all day long in the dev project, and they're safe. They know that production, the environment your actual users are connected to, is completely shielded from all that volatility.
That makes perfect sense for keeping things separate. But what about when they need to talk to each other? Isolation is the default, but an architect's job is often to poke very intentional, very secure holes in that wall.
And that's a key architectural challenge. So for example, if your production project needs to connect to a central shared logging service that's running in a totally separate platform shared services project, you have to explicitly configure that connection. You can't just stumble into it. This is usually done with highly controlled things like a shared VPC or VPC network peering. The project boundary forces you to be explicit and intentional about every single one of those cross-project connections.
Which is a massive security
A
advantage.
huge one. You don't get accidental access. Access is only ever granted when an architect has deliberately designed and configured it.
Excellent. So project boundary number 1 is this robust resource isolation and security governance. And that leads us right into role number 2, which is the one that the execs and the finance teams really care about:
Oh, yeah.
billing and cost allocation.
This is where the project container just delivers enormous clarity. Every single project has to be associated with one and only one billing account. And that association gives you the cleanest, most auditable way to track and allocate every single cent of your cloud spend.
So if I spin up a massive database or I run a huge BigQuery job, the charges are atomized and recorded right against that one project. Why is that link to a single billing account so critical, though?
Because it fundamentally simplifies financial governance
Yeah.
and chargebacks. I mean, think about a common scenario for a software consultancy or even an internal IT department. They're building apps for multiple distinct clients or business units.
Right, different cost centers.
Exactly.
Yeah.
So by giving each client its own project, client A app prod, client B app prod, they can link those specific projects to separate billing accounts, or at least a different cost center on the main account.
Which means that
When the invoice comes in, all the charges for client A's project are instantly visible and totally segregated from client B's. You're not trying to dissect this huge monolithic cloud bill with complex spreadsheets and tagging rules anymore.
that's a huge administrative headache removed.
The project just acts as the definitive financial identifier. It's clean.
Okay, but it gets tricky when we talk about shared services, right?
Right.
If I have a central networking team and they're managing a VPC that all my other application projects use, how do I allocate the cost for that shared thing?
That's a great question, and a major point of architectural complexity. While your app projects, like GameX Prod, are consuming their own resources directly, that central shared networking project is also consuming resources. Things like VPN gateways or dedicated interconnects.
Well, those are not cheap.
Not at all. So architects have to make a choice. Either you build that central project to a corporate overhead account, or you use the clarity of the project structure to calculate the usage share and implement an internal chargeback model to distribute those costs back to the projects that are actually using it.
But the project boundary at least makes that cost visible.
It makes it visible, yeah. Even if the allocation is still a managerial challenge. Visibility is half the battle.
It really is. Okay, let's move on to the third critical role. This one defines who gets to interact with the resources inside that cost boundary. We're talking identity and access management, or IAM.
Projects are the primary and usually the most granular enforcement point for IAM policies. This is a place where you grant specific roles and permissions, and not just to people or groups, but critically to the service accounts that represent your applications.
And that access has to be tailored exactly to what the project is for. I mean, we don't want a QA team member who needs access to staging accidentally getting permission to change the core network config in production.
Precisely. Let's take that classic dev versus prod example again. The development team, they need flexibility. They need to deploy, test, tear down, rebuild infrastructure constantly in their dev project.
Do you give them more permissions there?
Right. You might grant them a broad, pretty permissive role, maybe something like role senator, but only within that specific project boundary.
But the moment you look at the production project,
The whole access profile changes completely. For the production environment, that same development team might only get read-only permissions, or maybe a monitoring role like roles monitoring.viewer.
So they can see if something's wrong, but they can't touch anything.
Exactly. They can check logs, monitor performance, but they lack the fundamental permission to run commands that could modify, deploy, or delete mission-critical services. That project-level segregation is absolutely non-negotiable for operational security.
I want to circle back to service accounts on that because it's not just people, it's machine identities. Does the project boundary enforce those interactions just as strictly?
It does, and that's a key vulnerability if you mismanage it. If you have a service account in Project A and you wanted to access a resource in Project B, you can't just rely on some default permission.
You have to be explicit.
You have to explicitly grant the necessary IAM, role storage.object viewer, to the Project A service account on Project B. This mandatory, explicit cross-project role binding is the technical proof that the project boundary is a powerful default isolation zone for IAM too.
Okay, that brings us to the fourth critical role, managing scale and resource governance through quotas and limits.
Quotas are your safety valve. They're a resource management layer. A lot of GCP services like compute engine instances, persistent disk storage, or the number of API requests you can make to services like Cloud Vision or BigQuery, they all apply consumption limits, or quotas, at the project level.
So why is a project level quota so important? Why not just one big quota for the whole organization?
It creates that crucial control we talked about earlier, the blast radius.
Right.
Imagine you have a new experimental project running some computationally intensive, maybe error-prone batch job. If that job suddenly misfires and tries to spin up 500 VMs when it was only budgeted for 50, a project-level quota stops that failure immediately. It prevents that one runaway project from consuming all the available resources for the entire organization, which could potentially starve your critical production systems.
So it's all about stability and making sure resources are available across different business functions.
Exactly. For example, a project focused on heavy machine learning training that needs a ton of GPU processing power. It's going to need higher quotas for compute engine VMs and GPUs. Meanwhile, your static website hosting project might need really high limits on cloud storage I/O, but almost no compute engine quota.
And project segregation lets you do that.
It lets the administrator tailor resource allocation precisely to the business need. It ensures resources are distributed fairly and stops one project from wrecking the operational integrity of another.
Now, before we move on from the roles, we have to talk about a crucial architectural point, something that comes up on exams all the time and is often misunderstood: inheritance.
Yes. This is where the project boundary meets the corporate governance mandate. While the project is a boundary, it is not sovereign. It's not its own little kingdom.
It exists in a hierarchy.
Exactly. The organization is at the top, then you have folders, then the project, and finally the resources inside the project.
So if a policy is set way up at the top, the project owner, no matter how much power they have inside their own project, has to comply.
Precisely. Policies flow downward. The project owner might have the authority to do whatever they want to the resources in their project, but they absolutely cannot override constraints that are enforced by their parent folder or the overarching organization policy service.
Can you give us a concrete example, something that would completely handcuff a project owner?
A classic one is location restriction. The organization might mandate, for regulatory or compliance reasons, that all resources must reside in the US East 1 region. This is enforced at the organization level, using an organization policy constraint, something like constraints GCP.resource locations. So if the project owner then tries to provision a compute engine instance in, say, Europe West 3, the request will just fail immediately.
Even if they have role owner on the project?
Even then, they can't enable the resource because the organization has disabled that entire region via policy.
I see.
Another common one is requiring specific logging destinations. The organization can enforce a policy that says all projects must export their audit logs to a central managed log bucket. The project owner can't switch that off or redirect the logs. It ensures that central security monitoring is maintained across the board.
So that inheritance structure is what allows the central governance team to maintain standards across hundreds, maybe thousands of decentralized projects.
It's absolutely essential for enterprise governance. That distinction between IAM, who can do things, and organization policy, what constraints apply to everyone, is vital.
Okay, that's crystal clear. Now let's unpack the 3 technical identities assigned to every single project. This is where architects who are writing scripts and hitting APIs need to be absolutely meticulous.
This is a common trip-up point, yeah. Even for experienced folks. Every project has 3 identifiers, and if you mix them up, your API calls will fail, or worse, you'll target the wrong environment.
So we need to clearly distinguish between the project name, the project ID, and the project number.
Yes, three very different things.
Let's start with the easy one, the name.
The project name is just that. It's the human-readable display name. It's designed for you to quickly identify it in the GCP console dashboard. We see things like client a billing project or Q4 2024 backend development.
And what are its defining characteristics? Is it unique? Can you change it?
It is entirely mutable. You can change it anytime you want. If the Q4 2024 project rolls into 2025, you can just rename it to 2025 refactoring project and nothing breaks.
And it's not unique.
Critically, it is not globally unique. Your organization can have tons of projects with the exact same display name. That's why it's really only useful for display.
Okay, so that's the friendly name. Let's move to the heavyweight, the one that actually defines the project in the digital world, the project ID.
The project ID is the globally unique string identifier. This is the one that runs your cloud infrastructure. You use it in every single programmatic interaction, your Glide Cloud CLI commands, your REST API endpoints, and fundamentally, it's often embedded right into the URL or the path of your resources.
Can you give an example of how that immutability affects resource paths?
A prime example is cloud storage.
Mm-hmm.
When you create a storage bucket, that bucket's name has to be unique across the entire world. So architects will often prepend the project ID to the bucket name to guarantee that uniqueness. You end up with something like my dev own fee 12345 storage assets.
And that project ID, once you set it, it's part of the resource's identity forever.
Forever. It's baked in. And there are strict constraints on the ID itself. It is absolutely, irrevocably immutable. You cannot change it for the entire life of the project, and it's globally unique. The constraints are tight, 6 to 30 characters, and only lowercase letters, numbers, and hyphens.
No spaces, no caps.
Nothing else. Its immutability is why choosing a project ID requires real architectural foresight. We'll come back to that later.
Okay, so if we have the friendly name and the unique immutable ID, why did Google need a third identifier? The project number.
The project number is the true internal identifier. It's an automatically generated, extremely long, globally unique numerical string. For most of your day-to-day work, you don't even see it, but it's vital for Google's internal accounting and resource management systems.
So where does an architect actually run into a situation where they have to use the project number?
The most common place is when you're configuring security permissions that involve service accounts, particularly the default compute service account. That service account's email address is actually constructed using the project number, not the project ID.
Ah, I see.
Yeah, it's structured something like project number-compute at developer.gserviceaccount.com. So if you're setting up cross-project access with automation, you have to reference this numerical identifier.
So to recap, we have the human-friendly, editable name, the programmatic, unchangeable, unique ID,
the most important one for you,
and the internal, unchangeable numerical number for service accounts and internal stuff. It's really a hierarchy of identity built for different use cases.
Exactly. User experience, automation, and internal tracking. And if you're using infrastructure as code tools like Terraform or Cloud Deployment Manager, the project ID is the critical thing you define up front, and the project number is an output you might extract later for identity configuration.
That clarity is absolutely essential. Okay, let's transition now into the project's lifecycle. How we create them, what happens when they die, and crucially, how we protect the ones that can never, ever go away.
Project creation is that first step. It requires that immediate commitment to the name, the immutable ID, and linking a billing account. For anyone starting out, the prerequisites are pretty basic. A Google account, an active GCP billing account, and you'll want to be familiar with the G-Cloud CLI.
So once a project is up and running, the time will inevitably come when it has to be retired. But deleting something in GCP isn't like hitting delete on a file. It's not instantaneous. There's a grace period, what we call soft deletion.
Correct. When an administrator initiates a shutdown request for a project, say a test environment that's no longer needed, it doesn't just vanish into thin air. It enters a pending deletion state for 30 days.
Okay, so what's happening during that 30-day window? Are the resources still running? Can I still get to my data?
No. The project is immediately made unusable. The resources are effectively turned off and all access is blocked. But, and this is the key part, the system holds on to the data, the configuration metadata, and all the IAM policies.
So that grace period is the organization's big undo button.
It's the crucial safety net. It exists because Accidentally deleting a project is probably the most catastrophic user error you can make in the cloud.
So if someone catches the mistake, say, 2 weeks later, how do they bring that entire environment back from the dead?
Restoration is actually really simple. As long as you know the immutable project ID, you just use the command line. jcloud projects undelete projected.
One command.
That one single command reverses the deletion request. It brings the project and all of its resources, all its data, all its permissions back online, usually within a few minutes. But if you miss that 30-day window,
It's gone forever.
it's permanently purged. There's no getting it back.
The safety net is good, but what about the projects that are so mission critical? You know, your ERP systems, your core security services, your central networking hubs, that they can't even afford to enter that 30-day pending state. This brings us to a really vital security concept, project liens.
Project liens are the architectural equivalent of putting an unremovable padlock on that project container. The goal is to enforce a policy that explicitly prevents any form of deletion, period.
So even if I have the owner role on the project, the highest level of permission.
Yes.
Yes.
And that is the critical security detail. The lien overrides the authority of even the highest administrative role within the project. A user with the owner role, who can typically do anything, cannot delete the project if a lien is active.
So what do they have to do?
The lien has to be explicitly removed first. This is a critical defense-in-depth mechanism against, malicious activity or just a tired administrator making a mistake.
And that implies that you need a specific, separate administrative role to even manage the lien itself, right? Separate from the project owner.
Absolutely. To truly protect the project, the IAM role that can manage liens, it's often roles a resource manager.lien modifier or resource manager.lien creator, that role has to be granted to a different team. A security team, a governance team, maybe a service account dedicated to compliance.
Not the day-to-day project owner?
Definitely not. This separation of duties ensures that deleting the project requires cooperation across multiple governance layers. It makes accidental or road deletion far, far less likely.
And the implementation for this, it requires a specific, pretty advanced command. Can you walk us through the syntax and why the fields are so important?
The command uses the eCloud Alpha Resource Manager, liens create utility. When you create the lien, you have to specify two key parameters, the restriction and the reason.
Okay.
The restriction must be defined as resourcemanager.projects.delete. This explicitly tells GCP, do not allow the delete API call for this resource.
And the reason? Is that just for documentation?
It's mandatory for auditing and organizational clarity. A reason like protecting core financial services or central VPC network. If someone later tries to remove that lien, they have clear documentation as to why that security constraint was put there in the first place. It makes sure institutional knowledge doesn't get lost. This mechanism is really a foundational pillar for any highly regulated or mission-critical deployment.
Let's pivot now to the practical side of this. An effective GCP architect has to be fluent in both the console and the command line. So let's start with creation and retrieval.
When you're creating projects in the console, the interface really holds your hand. It guides you seamlessly. You click New Project, you fill in the project name, and the console immediately checks if your proposed project ID is globally unique. It often forces you to add a number or some unique suffix until you find an available ID. It's very user-friendly.
But for automation, for deployment pipelines, we live in the Kia cloud world.
Correct. The CLI is just way more efficient for anything at scale. You use dcloud projects, create project name.
Yeah.
And here's where the console often simplifies things that the CLI makes you do explicitly. Billing linkage.
That's right. It was noted that linking billing is often a necessary second step if you're using the CLI, especially if you're not inside an organization that automates it.
Exactly. Unless your org setup is configured to automatically inherit billing, you have to run a second command to make that financial connection. G-Cloud Beta Billing Projects link projected billing account. Billing accounted.
And if you skip that step,
Your resources might launch successfully, but they won't be chargeable, and GCP will eventually just disable them. And that leads to very unexpected outages.
okay, so a project is created. Now, the architect needs to get its metadata, especially that invisible numerical identifier we talked about. How do we pull that vital information using the CLI?
For a quick check of what you have, you just use G-Cloud Projects list. But for deep architectural work, that's not enough. To find the project number or other details like the parent organization or the billing account it's linked to, you need the detail command.
G-Cloud projects describe projected.
And since that command spits out structured data, how do advanced users usually handle that output?
Well, the output is usually in JSON or YAML format, so architects rarely read it by hand. They'll use the format JSON flag and then pipe that output into scripting tools like JQ.
So for example, if you need just the project number for a config file, you might run something like Arja Cloud Projects, describe my project ID format value project number. This programmatic extraction is absolutely essential for automation scripts that say configure service accounts on the fly.
That's the difference between just knowing the command and knowing how to use it in a large-scale automated environment. Okay, let's talk about renaming. We've hammered on immutability. So how do we change the mutable display name using the command line?
Renaming is straightforward, but it's a critical moment to remember that immutability constraint. You can only update the display name. The underlying ID and number are permanently fixed. To update the name, you just use IDKL projects update projected name, new project name.
And this simple operation brings up a huge organizational challenge, doesn't it? If the business unit associated with the project ID Acme Payroll 2018 gets rebranded or merged, you can change the name to reflect the new structure. But you're stuck referencing Acme Payroll 2018 in all your scripts forever.
It's an immutable stain on your architecture sometimes.
Yeah.
While the name change is cosmetic, the operational reality of that old project ID remains. This is why governance teams spend so much time standardizing project ID formats to make sure they reflect an organizational structure or function, not some transient name or date.
Let's dedicate a final detailed moment to walking through the command sequence for both the defense mechanism, the project line, and the disaster recovery mechanism, the restoration process.
This is a perfect summary of the lifecycle tools. Let's start with protection. First, you have to define your targets.
So we set our variables, let's say projected prod finance core and project name finance production.
Step 1. G-Cloud projects create prod finance core name, finance production. Step 2. Immediately after creation, you lock it down. You run that complex, powerful alpha command. G-Cloud Alpha Resource Manager leads create resource projects, prod finance core restrictions, resource manager.projects.delete, mandatory lock for core services.
And the second that command executes successfully, the lock is on.
It's on. If a senior engineer then tries to run G-Cloud projects, delete prod finance core, the CLI will just return an error. It'll say the operation is prohibited because of the active resource manager lien. That project is now architecturally safe from deletion until a governance team explicitly removes that lien.
Now, on the flip side, let's revisit the soft dilution and recovery scenario, the staging project example.
Okay, so we create a staging project, maybe staging web app queue. Then we run the delete command. G-Cloud projects delete staging web app queue.
And the project immediately goes into that grace period.
Yep. And to confirm it's there, we can use G-Cloud projects list filter e.staging web app-queue. We check the output and verify that the status says delete requested.
And the recovery?
We execute the recovery command. In G-Cloud projects, undelete staging web app queue. As long as we're within that 30-day window, the project is restored, it gets removed from pending deletion, and all its associated network configs and databases are brought back to a running state.
So those two mechanisms, the lien and the 30-day restore, give you robust safeguards for both proactive offense and reactive recovery.
Absolutely.
That practical flow really shows how robust the project management tools are. Okay, this brings us to our synthesis. Let's connect all these deep technical details back to the core architectural goals.
We started by establishing the project as the indispensable foundation. So let's distill the 4 critical takeaways you have to carry forward. First, remember the hierarchy and structure. This dictates how policy flows.
Organization at the top.
Handing constraints down to folders, which applies them to the project, which contains the resources. You can only control what your parents allow.
Second, the inescapable reality of immutability. You get one shot.
One shot at defining the project ID and number. They are permanent, fixed identifiers used in every single API call and resource path. Choose wisely, because only the display name can ever be changed.
Third, concerning security governance, you have to build defense in depth by using project liens.
They are the non-negotiable architectural locks. You use them to prevent accidental deletion of critical production environments, and they override even the project owner's privileges.
And finally, the operational imperative of isolation.
Projects give you default isolation for security, for resource consumption via quotas, and for billing. Any interaction across those project boundaries has to be explicit, intentional, and securely configured. It forces architects to stick to the principle of least privilege.
Master this structure, and you gain control over cost, compliance, and complexity.
The project is the single most important architectural component. It really is.
And as the sources point out, once you've really mastered containing resources within these projects, the next logical step in your learning journey is controlling access within that container.
That's the natural evolution, yeah. Implementing fine-grained IAM best practices for security, defining those specific roles and permissions that are needed inside the project boundary, making sure that even within a secure project, users only have access to the exact resources they require and nothing more.
Before we close out this deep dive, we want to leave you with one provocative thought to explore on your own. It ties directly back to that immutability factor we kept talking about, project IDs.
Think about the organizational implications of project IDs. If you choose an ID today, say, client at project 2024, and 3 years from now, client A is acquired by client B, and the application itself is completely refactored from version 1 to version 5.
That original ID is still hard-coded into everything.
It's in every storage bucket name, every API endpoint, countless legacy scripts. So the question for you is, what structural standards can your organization implement today to future-proof your project IDs? To make sure they're generic enough to survive mergers, acquisitions, and technology cycles that will inevitably make the original project name obsolete.
It demands that architects think less about today's label and more about tomorrow's longevity. It's really the difference between just tactical deployment and building an enduring cloud strategy. That's a wrap on our extensive deep dive into GCP projects. Thank you for joining us as we explored the foundational boundaries of the cloud. We'll see you next time.